Algebra 2 Cram, New York State, Algebra 2 Regents, Common Core, Key Facts, Trigonometry/Physics, Resultant Diagram. Question 10, Law of Sines and Parallelogram Rule. To order this complete Cram session, inbox me at memedicine@gmail.com. Be sure to spread the word to your friends and classmates who also need to cram for Algebra 2. And if this isn't the subject you're looking to cram for, also inbox me at memedicine@gmail.com so we can put a personal package together for you. All right, so again, inbox me at memedicine@gmail.com for pricing and ordering instructions. All right, let's delve into the question. Review question 10. Two equal forces act on a body at an angle of 70 degrees. If the resultant force is 100 newtons, find the value of one of the two equal forces to the nearest hundredth of a newton. And in case you're wondering, newton is the unit for force in physics. Okay. All right, so at this time, definitely press pause and I'll give you a moment to organize your answer. If you're not sure what to do, write something. And then set aside, a separate sheet of paper that's blank just in case your method is not the most efficient. All right, so the first thing that you're going to do is draw a diagram. And as you can see, I gave you a head start. I drew the two equal forces acting on a body at an angle of 70 degrees. And the resultant was drawn using the parallelogram rule, the resultant of 100 newtons, okay? And in case you forgot what a parallelogram is, it's a quadrilateral where both pairs of opposite angles are congruent, meaning that both pairs of opposite angles are equal, okay? And you have to be sure that the sum of the interior angles is going to equal 360 degrees. But let me demonstrate exactly what I'm talking about with this definition. The parallelogram rule of vector addition states that if two vectors have the same initial point, this is the initial point here, consider the parallelogram, okay? So here goes the parallelogram of those two vectors. And again, as you can see, it's a quadrilateral with four sides where opposite interior angles are going to be equal. And we're getting closer to illustrating that point. Okay, so we're considering the parallelogram with those vectors as adjacent sides. And the sum of those vectors is going to be the vector that forms the indicated diagonal, okay, of that particular parallelogram. Or in other words, you can say that the resultant, that would be the physics term for this diagonal, of these forces is represented in magnitude and direction. Here goes the magnitude, and the direction is indicated with the arrow by the diagonal of the parallelogram, okay? You still might be a little confused, but don't get hung up on the words. Just know how to draw this thing. That's more important, the actual doing of it, okay? And you have to take note that because the forces are equal, therefore, all the sides of the parallelogram are equal. And this is a special type of parallelogram. It's a rhombus. And again, in case you don't know what a rhombus is, it's a parallelogram with four equal sides where each diagonal basically is going to bisect a pair of, bisect each pair of congruent angles. But before we demonstrate that, we know that this angle is 70. So this entire angle, if you ignore the diagonal temporarily, is also 70. Therefore, this angle is going to be 110 and 110 because remember, the interior angles of a quadrilateral parallelogram have to add up to 360 and opposite interior angles are congruent to each other. Okay, so 110 here, and when you bisect 70 degrees, you get 35 degrees. So what we're going to do next is we're going to use this special guy here, and that's called the law of sines. We're going to use the law of sines basically to find the magnitude of one of these two equivalent forces. And we have authorization to use the law of sines to find the magnitude of a side because we already know two angles, 35 degrees and 110 degrees. And let me be specific. The law of sines is meant for a triangle and not a quadrilateral. So it just takes you seeing that there are two similar triangles here that have been formed after the bisector or the resultant force was formed, okay? All right, so yeah. So we know two angles and we know one side. So if this amount of information is known, we can then use the law of sines in order to find the magnitude of this force to the nearest hundred. Okay, and again, the law of sines states that in a triangle, the sines of the angles are in proportion to the sides directly opposite them. Thus, side A, and we'll let side A be the resultant force, this 100 Newton force. Side A divided by the sine of A, which would be 110 degrees, is equivalent to side B, which would be is going to be designated F, either way you put it, because this angle is going to be 35 degrees also, divided by the sine of 35 degrees. Or as a matter of fact, we'll switch. We'll let F represent the A series, and we'll let the known force, resultant force, and its angle of this angle of 110 degrees represent the B series. And C, it would be the same as B since these two sides are equivalent and the bisector divided the opposite interior angles equivalently, okay? So let's just demonstrate all this mumbo jumbo I'm talking to you. Therefore, when we plug in our values, we get that F, you could say this F, divided by the sine of 35 degrees is equivalent to the ratio of 100, side B, divided by the sine of 110 degrees, okay? And when we cross multiply in an effort to find out what F is, we get F, the sine of 110 degrees, is equivalent to 100, the sine of 35 degrees. Next, we're going to divide the left-hand side and the right-hand side by the sine of 110 in order to isolate F by itself. And we get that F is equivalent to 100, the sine of 35 degrees, divided by the sine of 110 degrees. Now what you want to do is go to your calculator and plug this in. And if you don't know how to do this properly, inbox me at memedicine@gmail.com and you can order a brief video of me showing you how to do this. And you have to be sure that your calculator is in degree mode, okay, so that you can get the proper answer. You have to make sure that it's not in radian mode or you'll get the radian version of this answer, or it could produce an error if you're not in degree mode, okay? All right, so this is going to be equivalent to 61.0387, and the units of the side is newtons, but we're asked to find the measure of the forces to the nearest hundredth. So when we find out F or one force, we know the rest of them. Therefore, F is equivalent to 61.04 newtons because the 3 in the hundredths place rounds up to 4. Okay? All right, so this is our answer. And let's move on to the next series, okay? And definitely, again, inbox me at memedicine@gmail.com so I can dismantle your paradigm regarding math if you have this subconscious recurring feeling that you're not capable of doing it. Anyone is capable of doing this, especially if I'm capable you're definitely more than capable. Okay? All right.